Hello and welcome to the Week 6 Grade Data Science Solutions for the course Statistics for Data Science 2. So coming to the first question, the joint PDF of two continuous random variables x and y is given. Fxy of x comma y is given as 4xy when x is in the range 0 and 1 and y is in the range 0 and 1. And we have been asked whether x and y are independent. As you know, for checking the independence of any two random variables, we can just find their marginal PDF and check if the joint PDF is equal to the product of the marginal PDFs of the two random variables. If they are equal to the joint PDF is equal to the product of the marginals, then it is independent. So we will just use that property here. So first of all, we will have to calculate the marginal of x and y. So we can write the marginal of x as the integration of the PDF 4xy with respect to y and in the range of y. So y goes from 0 to 1. So if we integrate it, we will get 4xy squared by 2. So it will be 2xy squared between y equals 0 and 1. So it will be just 2x. So 2x is the marginal PDF of x. And marginal PDF of y, while calculating the marginal PDF of y, we can, here it should be y. So while calculating the marginal PDF of y, what we can do, we can integrate the PDF with respect to x goes from 0 to 1. So in this case, it will be 2yx squared and x goes from 0 to 1. So finally it will be 2y. So what is the product of the marginals? Fx at x and fy at y, it is equal to 4xy, which is equal to the joint PDF of x and y. So the conclusion comes out that x and y are independent. So coming to the second question, we have been given two random variables x and y which are uniform in the range D, where the region D is given by this condition. D is the set of all points where this condition holds, x minus k squared plus y minus k squared is less than or equal to r. And we have to calculate the probability that x is greater than y. So first we have to understand what kind of region this represents. This region D represents. So what we will do, x minus k squared plus y minus k squared is equal to r. So we will first consider this equality instead of the inequality. So this clearly represents a circle which has a radius under root r, and its center is at k and k, coordinates k and k. But we have not been given what is the value of k. So let's try to imagine this circle. So here are all the points, 1, so its center is located at k and k. So it can be located along this line x equals y. Why? Because its center can be there at 1 1, 2 2, 3 3, and even in the negative direction this circle can be located with radius under root r. So but we don't know where this is located because we don't know the value of k. So suppose it's located at any point k. This is point k. I don't know which point it is. So the point will be here. So it's not given that it is between 1 and 2, but for simplicity we are assuming it's here. So we will draw a circle around it. So yeah, this is my best attempt to draw a circle. So this is a circle. Now we have been given the region D represents all the points, this points x minus k squared plus y minus k squared, set of all points x and y where this is less than or equal to r. So clearly at this boundary of the circle, this condition holds, equality holds. So clearly the area, x minus k squared plus y minus k squared less than equal to r will represent the region inside the circle. So that is clear. This region represents this inequality. Okay, so we have to find the probability that x is greater than y. So what we used to do in this kind of problems, first we will try to understand what is x is equal to y. So x is equal to y is clearly a line which passes through these points 1 1 2 2 and so on. So x equals y passes through these points, and x greater than y, which side does it correspond to? So on this line x is equal to y or y is equal to x. Let's write x equals y. On the right side of the line, clearly x is greater than y, and on this side of the line x is less than y. So we have to find the probability that x is greater than equal to y. So clearly we have to find the probability that xy will fall in this region of the support. So the support is the full area of the circle, full region of the circle, but we have to find the probability that xy will fall in somewhere around in this region. So we have been given that in this region of the circle, the PDF is uniform. So when the PDF is uniform, the calculation of the probability becomes much easier. What we do, we just calculate the area of the, where we have to calculate the probability, which area, and we divide it by the total area. So clearly what we have to do, we will have to calculate the area of the full region that we will represent with D. So area of D will be half times pi r squared. Here the radius is under root r, so it will be r. So pi r by 2. Now this is the required region where we have to calculate the probability. It will be half times. So half times the area of the circle, right? So pi r by 2. So it's clearly pi r by 4. Now the probability that x is greater than y, it will just be the region where we have to calculate the probability, the x and y falling in that region, that is area A divided by area D. So clearly we can write pi r by 4 and pi r by 2. So it will be half. In question number 3, we have been given two random variables x and y which are uniformly distributed in some region D, where D is the union of two small regions. We have to find the marginal density of x. So first of all, let's try to understand joint PDF of the random variables x and y in that region, and then we will be able to find the marginal density of x. So D is the union of two regions. So let's try to graph the regions. I'm not writing points beyond 2 in the graph because in all the situations, the limit for the random variables x and y, you can see it is only up to 2, so we can ignore beyond 2. So first of all, we have a line y equals 2x. So this line will be like this, can go beyond this also. So we have to consider all the region where y is less than equal to 2x. So clearly this side of the line represents all the region where y is less than equal to 2x. And we have to only consider the points where x is in the region in the range 0 and 1 and y falls in between 0 and 2. So x falls in the up to here and y only up to 2. So only up to this we have to consider. Okay, so only this region gets counted in this case. The first region corresponds to this. Now its union with the second region. What is the second region? Second region is where x goes from 1 to 2 and y goes from 0 to 2. So x goes from 1 to 2 and y goes from 0 to 2. So clearly this region. So union of both of these regions represents the support of x and y. So we have to find the marginal density of x. So first of all, for that we will have to find the joint PDF of x and y. But it's given that in this region the density is uniform, probability density is uniform. So we can just calculate the area and then find the PDF. So here the area of the support is equal to half times 2 times 1 plus 2 times 1. So it's 1 plus 2, 3. Area of the support is 3. So the PDF of x and y will be equal to 1 divided by the area of the support, that is 3. So we have got the joint density of x and y. Now we need to find the margin density. So as you know, this is the region of the support, and at every point you can imagine that the joint density function is protruding out of the this screen, and it's constant at 1 by 3. So you can consider that z-axis is coming out of this screen, and it's uniform at every point. And what we have to do, we have to take a slice here at any point, at any given point x. So consider this is x, and we have to add all the PDF. So if this is a volume, now the marginal, if you calculate at any point, it will represent an area. And what we have to do, we have to find the area of that. So you can see here that when you draw this line at any point in this support region, it will be different. So at this point it might be different, at this point it might be different, and at this point, all of these points after 1, it will be constant, the marginal PDF of x. So first let's try to calculate what it will be between 0 and 1 when x takes value between 0 and 1. It will depend on the value of x. What will it be? So we will have to integrate the PDF for calculating the marginal of x. So we will integrate it with respect to the other random variable y, the PDF 1 by 3 dy. We will integrate from y equals 0 to y equals, so what's the coordinates of this point? If it is equal to x, it will be x and 2x. So height of this point is 2x. So we have to integrate from y equals 0 to 2x. If you integrate this, it will be y by 3 between 0 and 2x. So it will be 2x by 3. So you can see that it is dependent on the value of the x. So this we have found when x is between 0 and 1. Now when x is between 1 and 2. So for that we will have to take a slice here and we have to find that area. So what we will have to do, we will have to again integrate with respect to y, but at any point the limits of the integration will be same, so this area will also be same. So y goes from 0 to 2, it will again be y by 3, y goes from 0 to 2, so it will be equal to 2 by 3. So the PDF marginal density that was attained at 1 remains constant after 1 and up to 2. So we can summarize this information and write it as marginal PDF of x is equal to 2x by 3 when x is between 0 and 1. It is equal to 2 by 3 when x is between 1 and 2, and it's 0 otherwise. In question number 4, we have been given the joint PDF of two random variables x and y. Fxy of x comma y is equal to 24xy when x is in between 0 and 1 and y is between 0 and 1, and x plus y should be less than equal to 1 and it is 0 otherwise. Then we have to check whether these are independent and dependent. So let's first try to graph this region, and then we will find the respective probabilities. So x and y, x goes from 0 to 1 and y also goes from 0 to 1 only up to 1, and x plus y should be less than equal to 1. So you know that x plus y is equal to 1 is a line, this line. So x plus y less than equal to 1 will be this side of the line. So this is the support. Now we need to find the probability x plus y is less than equal to 1 by 4 and verify if it is equal to 1 by 2. So here also we can imagine this is 1 by 4 and 1 by 4. This is the line x plus y equals 1 by 4, and this region x plus y less than equal to 4 corresponds to this yellow region. And we have to find the probability that the random variables x and y will take values in this range. So for that we will have to integrate the PDF over this region. So what we can do, we can consider any vertical strip here, and we can first integrate the PDF along this strip, and then that strip will go from this beginning to x equals 0 to x equals 1 by 4. So first let's try to write the coordinates of the points. So this we have imagined as any arbitrary point x, and clearly the y coordinate is equal to 0. What about this? So it will clearly also have x coordinate as x, but y will be, if we try to write it in terms of x, it will be 1 by 4 minus x. So first we have to integrate along this strip, and then that strip will go from 0 to 1 by 4. So y equals 0 to y equals 1 by 4 minus x, and then finally x will go from x equals 0 to x equals 1 by 4. What are we integrating? We are integrating 4xy dy dx. So let's do this inner integration first. So 24xy dy, y goes from 0 to 1 by 4 minus x. So it will be 24xy squared by 2. So 12xy squared between 0, y equals 0, and 1 by 4 minus x. So it will be 12x, just putting the value of y here, 1 by 4 minus x squared. So let's simplify this. It will, if we take out 4 here, it will come out as 16. So 12 by 16, that is 3 by 4, x times 1 minus 4x squared. So we can put that here, x equals 0 to x equals 1 by 4 and 3 by 4 x times, and here we can expand 1 minus 4x whole squared, so it will become 1 plus 16x squared minus 8x, and we can further 3 by 4 x equals 1 by 4 x plus 16x cube minus 8x squared dx. So now we need to integrate it. X squared by 2 plus 16 x raised to the power 4 divided by 4. So it will become 4x4 minus 8x cubed by 3, and x will go from 0 to 1 by 4. So it will be 1 by 32 plus 1 by 64 minus 1 by 24. If you simplify all of this, you will get it is equal to 3 by 4 times 192 that will be equal to 1 by 256. So this is the probability that x plus y less than equal to 1 by 4. So clearly it is not equal to 1 by 2, so the first option is incorrect. So this we checked for the option number 1. And next we need to check for option number B. So the second option asks for similar probability, but the only difference is there in the limits. So this is half and this is also half. We can imagine another strip here that goes from x equals 0 to x equals 1 by 2. The important thing here is the coordinates of the points. So here this we can consider as x comma 0. The y coordinate is 0, and this will be x comma, in this case it will be 1 by 2 minus x. So you would have understood that first we will integrate along the strip and then from x equals 0 to x equals 1 by 2. So the probability that x plus y, this is for option number B, x plus y less than equal to 1 by 2, which will be equal to, first we will integrate it from y equals 0 to half minus x along the vertical strip, and finally we will integrate it from x equals 0 to half, x equals 0 to half, 24xy dy dx. So first let's do the inner integration that we have already done in the previous case, but the limits are different in this case. 24xy dy, which is between y equals 0 to 1 by 2 minus x, which we integrated earlier also, and we found it was equal to 24xy squared, 12xy squared, from y equals 0 to half minus x. So it will be 12x half minus x squared, or 3x 1 minus 2x squared. So we can put it here, x equals 0 to half, 3 we can take out, it will be x plus 4x squared times x, so it will become 4x cubed minus 4x, so 4x squared dx. Now we will integrate it, x squared by 2 plus 4x raised to the power 4 divided by 4, so it will be x to the 4 minus 4x cubed by 3, and it will go from x equals 0 to half. So let's put the values here. So it will be 1 by 8 plus 1 by 16 minus 1 by 6. And if you simplify it, you will find it is equal to 1 by 16. Yeah, so it is indeed equal to 1 by 16. So the second option is correct. So probability that x plus y less than equal to 1 by 2. Now the last two options are asking whether these are independent or dependent. For that we will need to calculate the marginal PDFs of x and y, and then check whether the product of the marginal PDFs is equal to the joint PDF of x and y. So first we will calculate the marginal PDF of x. For calculating the marginal PDF, what we need to do, we will need to calculate a similar integration that we did for these cases. So but we will do only along one direction. So if we take some particular value of x at this point, if we add all the PDFs, or if we integrate the PDFs along this strip, then what will be its value? And it will definitely depend on the strip at which point this strip is located, because at every point the value of the height of the strip is different. So we expect it to be a function of x. So again the coordinates of this point will be nothing but x comma 0. This is some arbitrary point x comma 0, and this will be x comma, in this case it will be 1 minus y, because we are integrating up to this line x plus y equals 1. So what we need to do, we need to integrate 24xy, and along with which direction we need to integrate it, along y direction. Y goes from 0 to 1 minus x. So again the integration will be 12xy squared from y equals 0 to 1 minus x, which will be 12x 1 minus x squared. So this is the marginal PDF of x. Now we need to find the marginal PDF of y. So what we will do in case of marginal PDF of y, we will integrate only along this horizontal strip. Okay, we can consider this a very small strip, and at this point there will be some coordinate. What will be the coordinate? It will be x equals 0 and y equals some arbitrary y. So at some arbitrary point y, what we are doing, we are integrating the PDF along this, integrating the joint PDF along this strip up to this point. So this point is, first the y coordinate is just y, and x coordinate in terms of y will be 1 minus y. So we will need to integrate from x equals 0 to x equals 1 minus y. So we are integrating with respect to the other random variable to calculate the marginal, right? So fy at small y will, x will go from x equals 0 to 1 minus y, 24 xy dx. So it will be 24 x squared y will go from x equals 0 to 1 minus y. So it will finally be equal to 12y 1 minus y squared. So if you multiply the marginal PDFs of x and y, it will be 144 xy 1 minus x squared 1 minus y squared, which is clearly not equal to the joint PDF of x comma y. So these random variables x and y are not independent. So the third option is incorrect and fourth option is correct. So second and fourth option are correct. In question number 5, we have been given the joint PDF of two random variables x and y. fxy at x comma y is given as 3xy times 1 minus x, where x falls in between 0 and 1 and y is in between 0 and 2. We have to find the conditional probability that x is greater than 1 by 2 given y has taken value 1. So as always, what we will do, we will write the conditional probability as joint divided by marginal. So in this case, joint would be nothing but the joint PDF. fxy, so y has taken value 1 and x is greater than 1 by 2. So both of these events have happened. Now in the denominator, we will write the marginal of y at 1. So these two things we need to calculate, and then we will be able to find out this probability. But it's better if we visualize this situation so that it's more intuitive to us. So okay, 0 1 2, so x goes from 0 to 1 and y goes from 0 to 2. So now how do you consider this joint distribution? So as you know, this is the support of x and y, and at every point there you can imagine that the joint PDF is coming out of the screen, and it's according to this function 3xy times 1 minus x. So you take any xy, you calculate this value, and that will be the height of the thing that is coming out of the screen. So you can even consider that the and axis that is coming out of the screen is a z direction, and it is a 3D curve or 3D plotting. So what we have to do, we have to take a slice at y equals 1. So we know that y has already taken value 1, and then we have to find the probability that x takes value greater than 1 by 2. So let's try to visualize this density function on GeoGebra. So what I have done here is I have plotted z equals 3xy times 1 minus x. So on the z direction, you will see the joint PDF of x comma y. So you can see this is what this joint PDF looks like. It looks very curvy and everything. So only in the positive direction you have to consider. So from 0 to up to this point 2, and from in the y direction, so this is the y axis, and in the x direction you only have to consider up to 1. So you can see how the joint PDF looks. So now what I will do here is I will put y equals 1. So when I put y equals 1, this is a plane that corresponds to y equals 1, and let's see the intersection here. So this is the intersection path of the joint PDF and the plane y equals 1. So when we consider that y equals 1, our support will be restricted only to this line. So I will remove that joint PDF now, and we will only see this, and you have to consider it only in the x direction only up to 1, and in the y direction only up to 2. So you can see what the joint PDF looks when you consider y equals 1. So we can see it along the y direction. So yeah, so this is the restricted support when y equals 1. So you can consider like this is a new distribution when y equals 1, right? And we have to find the probability that x will take value greater than 1 by 2. So this is x equals 1 by 2. So this is clearly like a function of one variable, and we have to find the probability that the random variable x will take value greater than half. So we will calculate the area that is after half and divide it by the total area when y equals 1. So that's what we have to do. And when you calculate the total area, it means you are calculating the marginal PDF of y at 1. And when you are calculating the probability that x is greater than 1 by 2, this area, then it means you are calculating the joint PDF of x and y when y equals 1 and x is taking value greater than half. So when we try to visualize the joint density function when y takes value 1, okay, we will not write y here. Instead, we will write the joint density function when y has taken value 1. So when y takes value 1 and x takes value 0, it will be equal to 0. The joint density function will be 0. So we saw there that it was something like a parabola. It was 0 at 0. The joint density function will be 0 at 0 and also at 1. And it will be something like a parabola. So this is x equals half. And we have to find out the probability that it will take value greater than this. So this was all about the visualization of this conditional probability. So first we will calculate the total area. That will be the margin of y at 1, and then calculate this area. We will divide them, and then we will find the required probability. So for calculating the marginal at 1, what we can do, we can integrate from x equals 0 to 1. We will integrate 3xy times 1 minus x dx. We will integrate with respect to the other random variable x. So it will be x equals 0 to 1 xy minus x squared y dx, which will be equal to x squared y by 2 minus x cube y by 3. It will be x equals 0 to 1. So 3 times y by 2 minus y by 3. So it will be y by 6, which will finally be y by 2. So this was the marginal density at y. So sorry, here we calculated for a general y, and then when you put y equals 1, you will get the marginal PDF at that point will be half. So the area of the full region is equal to half. Now we need to find the probability that x greater than half. So now what we will do, we will put y equals 1 and x equal to half to x is equal to 1. Half to 1 we will need to integrate. And what we will integrate? We will integrate when y takes value 1. So 3x times 1 minus x we will integrate. 3x times 1 minus x. So if we integrate this, we will get 3x squared by 2 minus 3x squared, so 3x cubed by 3, so it will just be x cube, x from half to 1. So it will be 3 by 2 minus 1 minus 3 by 8 minus 1 by 8. So it will be half minus 2 by 8, that is 1 by 4. So it will be 1 by 4. So this is, what is this? This is this fxy x greater than half given y has taken value 1. So now we can find out the required conditional probability that we have to find. So probability that x greater than half given y has taken value 1, it is equal to 1 by 4 divided by 1 by 2. So it will be equal to 1 by 2. So this is the conditional probability that we have to find. In question number 6, we have been given that the amount of milk in liters in a shop at the beginning of any day is a random amount x, from which a random amount y is sold during that day. Assume that the joint density function of x and y is given by this. fxy at x comma y is equal to 1 by 50, where x is between 0 and 10 and y is between 0 and x, and it's 0 otherwise. So we have to find the probability that amount of milk left at the end of day is less than 5 liters. So here in the definition of the PDF, you can see that the range of x is from 0 to 10, and x represents the amount of milk in liters at the beginning of the day. So the amount of liters that can be there in the shop at the beginning of the day can be any value between 0 and 10. And from that milk, some milk will be sold during that day, and that we are representing with y. But we have to find the probability that amount of milk left at the end of day is less than 5 liters. So x was the milk that was there at the beginning of the day in the shop. We subtract the amount of milk that was sold during the day, then it will represent the amount of milk that is left at the end of the day. And we have to find the probability that the amount of milk left at the end of the day is less than 5 liters. So x minus y is less than 5. This probability we have to find. So first of all, it would be better if we visualize this situation of probability density functions and random variables. So we can do it up to 10. 5, 10. In the y direction also, we can do up to 5 and 10. So x represents the amount of milk at the beginning of the day, and y represents the what is being sold in the day. So as you can see here, if we have some x amount of milk at the beginning of the day, then the maximum amount that can be sold during the day would be x, right? So if suppose this is the x that is beginning at the beginning of the day, you have this much milk. So the maximum amount of milk that can be sold during the day would be x, but it can be even lower also, right? So for any point this is true. So if we consider any other point, it will be like this. So these are all the possible values of x and y that can happen. So it cannot happen that you have x amount of milk, or suppose at this point 5 liter of milk during the beginning of the day, and then you are able to sold more than 5, suppose 6 liter. So this cannot happen, right? So the only feasible region where x and y can take values are this. So at 10, the maximum amount of milk that can be sold during the day will be 10. So let's draw here. Yes. So clearly this is the support. Now we have to find the probability that x minus y is less than 5. So let's try to understand what is x minus y equals 5 as always. So when x equals 10, y equals 5. So y equals 5 at this point. So let's do in some other color. And when x equals 5, y equals 0. So these are the 2 points that are on that line. So clearly this line represents x minus y equals 5. So now you can clearly observe here that the right side of the line on this side, x minus y will be greater than 5. X minus y greater than 5. And here x minus y will be less than 5. So clearly we have to calculate the probability that the random variable x and y takes values in this region, represented by this region. Now one more thing is here, that the joint density of x and y is uniform in the support. So it means that we can calculate the probability by finding the area of the required region, that is this region, divided by the total region of the support, total area of the support. So the area of this region will be equal to the area of the larger triangle minus area of the smaller triangle. So if we represent this area with A, area of the region A will be equal to the area of the bigger triangle, that is half minus 10 times 10 minus area of the smaller triangle. So it is 5 times 5. So it is 50 minus 25 by 2. So it is equal to 75 by 2. So 75 by 2 is the area of the this region A, that we have to find the probability that x and y will take values in this range. Now what's the area of the full support? If we represent full area with D, then it will be half times 10 times 10, that is 50. So the probability that x minus y is less than 5 will clearly be equal to 75 by 2 divided by 50, or 75 by 2 times 50, so 0.75. So this is the probability that the amount of milk left at the end of the day is less than 5 liters. In question number 7, we have been given the joint PDF of two continuous random variables x and y. F x y at x comma y is equal to k times e raised to the power minus x plus y, x greater than 0 and y will be greater than 0, and it's 0 otherwise. And we have to find the probability that x will be greater than or equal to 5 and y will be less than or equal to 5. So we have to find some joint probability in terms of x and y. For that we will need to know the complete information about the joint PDF of x and y. Yes, we have been given the formula for the joint PDF, but here there is an unknown that we don't know, k that we don't know. So finding the value of k, what we can do is we can integrate this PDF expression for the full range of x and y, and then we will be able to equate it to 1, since we know the total probability should add up to 1, and then we will be able to find the value of k. So let's integrate the PDF. So x equals 0 to infinity, y equals 0 to infinity. So that's the range of x and y. K times e raised to the power x plus y. First we will integrate with respect to y, then with respect to x, and that should be equal to 1. So before doing the complete integration, what I will do is I will do the inner integration separately. So y from 0 to infinity k times e raised to the power minus x plus y dy. So we can take the e raised to the power minus x constant because the integration is with respect to y, and then we will be left with y equals 0 to infinity e raised to the power minus y. When you integrate e raised to the power minus y, it will become minus e raised to the power minus y. So we will take minus 1 also constant outside. So finally it will become minus e raised to the power x. We have integrated. This is the integration value. Y equals 0 to infinity. So what it would be equal to? It should be 1 by e raised to the power infinity. So that will be 0 minus 1 by e raised to the power 0. That will be 1. 0 minus 1. So finally it will be equal to e raised to the power minus x. And everywhere I have left the k, so let's not keep it here. So k I can also take out here, and then we will integrate with respect to x. X equals 0 to infinity e raised to the power minus x. So when you integrate e raised to the power minus x, it will become minus e raised to the power minus x. So minus 1 then again we can take out as constant, and we will get minus k outside. E raised to the power minus x integrated from x equals 0 to x equals infinity. So it will be equal to minus k e raised to the power minus infinity, that will be 0, minus e raised to the power 0, that will be 1. So we will finally get k, and that has to be equal to 1. So we find that the value of k is equal to 1. So what we get? We get that the joint density of x comma y is just e raised to the power minus x plus y, where x greater than 0 and y greater than 0, and it's 0 otherwise. So now that we have got the complete information about the distribution, we can find this joint probability that we have to calculate. So what is the required probability? Required probability is probability that x greater than equal to 5 and y less than equal to 5. So probability that x greater than equal to 5 and y less than equal to 5. So clearly we will need to integrate the joint density function e raised to the power minus x plus y. So in the inside we can integrate it with respect to y. So y will go from y equals 0 to 5, and x will go from 5 to infinity greater than 5. First we are integrating with respect to y and dx. So this is the integration that we will have to find out. So first of all I will do the inner integration. Y from 0 to 5, we can break it up. We can take e raised to the power minus x constant outside. We will be left with minus y dy. So when you integrate e raised to the power minus y, it will become minus e raised to the power minus y. So minus 1 we can take out as constant. So it will be minus e raised to the power minus x, and we get e raised to the power minus y. Y equals 0 to 5. So finally we have minus e raised to the power minus x. When you put e raised to the power minus 5 minus 1. So finally it will be e raised to the power minus x 1 minus e raised to the power minus 5. So this is this integration that we can put here now. X goes from 5 to infinity. So we can write here 1 minus e raised to the power minus 5 and e minus x. So then again we will integrate. It will become minus e raised to the power minus x. So we can again invert it. E raised to the power minus 5 minus 1 e raised to the power minus x from 5 to infinity. So it will be, when you put infinity, e raised to the power minus infinity, that will be 0 minus e raised to the power minus 5. So the final probability will be equal to, we can take minus 1 inside, so it will become e raised to the power minus 5 times 1 minus e raised to the power minus 5. So this is the probability that x will be greater than or equal to 5 and y will be less than or equal to 5. In question number 8, we have been given the joint PDF of two random variables x and y. fxy at x comma y is equal to 1 by 8 times x plus y, where x ranges from 0 to 2 and y ranges from 0 to 2 and it's 0 otherwise. We have to find the value of the probability that y will take value between half and 1 given x has already taken the value half. So it means we have to find some probability that y will take some value given x has already taken some value. So it is a conditional probability. So let's first write this probability that y falls in between half and 1 given x equals half. So it means if we are able to know the conditional distribution of y given x has taken some value, then we will be able to find this probability. So we need to know this PDF, conditional PDF y given x has taken some value half. So this will be equal to the joint of y taking some value small y and x taking value half divided by the marginal of the event on which it is conditioned. So marginal of x taking value half. So we need to find these two things, then we will be able to find. So for this joint probability, we can just substitute x equals half in the PDF expression, joint PDF expression of x comma y. So it will simply be half times half plus y. So joint is very easy to find. But what about the marginal of x? So let's calculate the marginal of x. Let's do it here. Marginal of x is equal to, we will integrate for all the values of y. So y will go from 0 to 2. What are we integrating? We are integrating half times x plus y dy. So it will become half, we will take out, then we will be left with xy plus y squared by 2. Y goes from 0 to 2. So the marginal of x will be simply equal to half times 2x plus 2, which will be just equal to x plus 1. So now marginal at half, we will calculate, that will come out as half plus 1, that is 3 by 2. So this is equal to 3 by 2, marginal of x. So it means we have been able to find out the conditional probability or conditional PDF of y given x has taken value half. It will be equal to 1 by 6 plus y by 3. Now we will finally find out the probability that y takes values between half and 1 given x has taken value half. We already know the corresponding PDF, right? So we can just integrate it. So we will integrate it from y equals half to 1. We will integrate if y given x equals half comma y dy. So if we integrate it, what will we integrate? Y equals half to 1. Okay, 1 by 6 we can take common, so it will be 1 plus 2y we will integrate. So which will finally be 1 by 6, and y plus 2y squared by 2, that will just be y squared between y equals 1 to equals half to 1. 1 by 6, then 1 plus 1, it will be 2, minus half plus 1 by 4. So it will be 3 by 4. So 8 minus 3, 5 by 4. So 5 by 24. So this is the probability that y will take values between half and 1 given x has taken value half. In the ninth question, we have been given that the joint density function of two random variables x and y is given by fxy at x comma y is equal to 2 by 3 times x plus 1. And x and y both are in the range 0 and 1, and it's 0 otherwise. We have been asked whether x and y are independent. So as you know, whenever we need to check whether two random variables are independent or dependent, what we need to do? We need to calculate their marginal densities and check whether the joint density of those two random variables is equal to the product of the marginals. If they are, then they are independent. Otherwise, they are not independent, right? So first of all, we will calculate the marginal of x. That will be, we will integrate y from 0 to 1. We integrate over the random variable that we don't want, right? So we don't want y, just want x. So we will integrate the PDF, joint PDF with respect to y over the full range of y. So here in the joint PDF, we can take 2 by 3 outside, and we will have x plus 1 dy. When we integrate it with respect to y, it will become xy plus or x plus 1 y. Y goes from 0 to 1. So it will be 2 by 3 times x plus 1. So this is the marginal of x. Now calculating the marginal of y. So in this case, we will integrate over x, all the values of x. So x plus 1 dx. So if we integrate it, it will be x squared by 2 plus x going from 0 to 1. So finally, so putting x equals 1, so it will be half plus 1, that is 3 by 2, and then x equals 0, it will become 0. So finally we will have just 3 by 2. So the marginal of y is simply a constant, that is 1. So now let's check what's the product of the marginals. So fx at x times the marginal of y, it is equal to 2 by 3 x plus 1 times 1. So it is just equal to this, which is clearly equal to fxy at x comma y. So it means these random variables x and y are independent. The 10th question is based on the same joint PDF, but here we have to find the value of probability that x will take value greater than y. So we have to find the probability that x will take value greater than y. So it will be better if we imagine this joint PDF and then proceed here. So here x falls in the range 0 and 1 and y in the range 0 and 1. So it will become, so this is the support, and the joint PDF is dependent on x but not y. So you will observe that at every point the joint PDF will be coming out of the screen, and it will vary according to x, and if it would have been a function of y, then it would have varied according to y also, but here in this case it will just vary based on x. Now we need to find the probability that x will take value greater than y. So as always, we will first draw what is x equals y. So clearly x equals y represents this line. It will definitely pass through 0 0 and 1 1. So this is the line x equals y. X is equal to y. Now we need to find the probability that x greater than y. So clearly it is talking about this region, this orange region. So for calculating this, what we need to do, we will need to add all the PDF's value or integrate all the PDF within this region. For integrating this, what we will do, we will take any small strip in this region, okay, here at any point, very thin strip. First we will integrate along this strip, and then we will continue it from x equals 0 to x equals 1. Okay, so it will simply be equal to the integration of, so this is something, the coordinates of this is equal to some x, and y is 0 at this point. What about the coordinates of this? The coordinates of this is already x coordinate is x, and y is also x, right? Because x is equal to y. So we need to integrate first along this strip. So we will integrate along the y direction. Y will go from y equals 0 to y equals x, and then we will integrate along the x direction. So it will, this first step you can imagine that it's at the 0, and then it's moving, and we are integrating for all such steps. So on the outside we are keeping x equals 0 to x equals 1. And what we are integrating? We are integrating the joint PDFs. X plus 1 first with respect to y, then with respect to x. So let's do this inner integration separately so that it's easy. So x plus 1, y goes from 0 to x dy. So it will be 2 by 3 x plus, so we are integrating with respect to y. So x plus 1 times y goes from 0 to x. So it will be x plus 1 times x. So finally here we will have, this is the inner integration, and here what we will have, x equals 0 to x equals 1, 2 by 3 we can take outside, and we will be left with x squared plus x dx. So when you integrate it, it will be x cubed by 3 plus x squared by 2, goes from x equals 0 to 1. So if we put x equals 1, it will be 1 by 3 plus 1 by 2. So it will be 5 by 6. So 2 by 3 times 5 by 6. So it will be 10 divided by 18. So this is the probability that x will take value greater than y. In question number 11, we have been given that Ria leaves for a school between 7 am and 7:15 am. She takes between 20 and 30 minutes to reach the school. Let x denote her time of departure and let y denote her travel time. Assuming that x and y are continuous, independent, and uniformly distributed, find the probability that she reaches the school before 7:30 am. So first of all, here we have been given two random variables, x and y. X and y. What does x represent? X represents her time of departure, and x can take values between, can take values in the range 0 and 15. So we can consider the number of minutes after 7 that she leaves from her house. So it can be between 0 and 15. So that value is taken by x. And what about y? Y is her time of travel, okay, or travel time. Travel time. And it can take values. It can take values between 20 and 30. So assuming that x and y are continuous, so it is given that x and y are continuous, these are independent and uniformly distributed. So the first thing that we can do is we can plot it so that we will have a visual picture of what's happening here. So this is x, this is y. So here we are representing time of departure. Time of departure, and here we are representing on the y-axis travel time. So travel time will be between 20 and 30, and it will be time of departure will be between 0 and 15 up to this point. So just for the sake of simplicity, I am okay. Up to here we have to go, and 20 to 30, and we can go from 0 to this 15. So clearly this region represents the support, all of the values that x and y can take. And it's given that x and y are continuous, independent, and uniformly distributed. It means their joint PDF will be uniform. So we can calculate joint PDF very easily. Fxy at x comma y, simply 1 divided by the area of this region, area of the support. So it is clearly 10 times 15, so it is 150. We need to find out that she reaches the school before 7:30 am. It means that if we are considering x as the time of departure and y as the travel time, then x plus y will in total represent the time at which she arrives at the school. And we need to find the probability that she reaches the school before 7:30 am. So clearly we need to find out x plus y is less than equal to 30. This probability we need to find out. So as usual, what we will do, we will first draw a line. So x plus y less than equal to 30 will represent a region, but x plus y equals 30, it will definitely represent a line, and this line will be from along this direction. So x plus y should be less than 30. It means we have to find the probability that the random variable x and y will fall in this region. We can find out the area of this region and divide it by the total area of the total support. In this way, we will be able to find the probability that our x and y will fall in that region. Because x and y are uniform, we don't need to necessarily integrate the probability. So we need to find out where this line x plus y equals 30 and this line y equals 20 intersects. So if we put y equals 20 here, we will find out this is 10, right? So it will be the coordinates, x coordinate will be 10 and y coordinate is 20. So this probability will simply be equal to the region. This region we can represent with A, and the total region we can represent with D. So this is D. So the probability, this probability will be equal to area of A divided by total area of the support. So area of the required region where xy has to fall into, so it will be half times 10 times 10 divided by area of the full support that we earlier found out. It is 10 times 15, 150, right? So it is equal to 50 by 150, which is equal to 1 by 3. So this is the probability that Ria reaches her school before 7:30 am. In question number 12, we have been given the joint density function of two random variables x and y, fxy at x comma y. So this should be fxy at x comma y is equal to k times x plus 2y for x in the range 0 and 1 and y is in the range 1 and 2. And the joint PDF is 0 otherwise. We have to find the value of k. So we can use here the property of any probability density function. That is, if we integrate it over the full range of all the random variables for which it is defined, then we will get it equal to 1. It's equivalent to saying that the probability, if we have a random variable and if we add all of the probabilities for all of the possible values, then it should be equal to 1. So we will integrate the PDF function. First we will integrate it with respect to x over the full range of x. K times k we can take outside, k times x plus 2y. We are first integrating it with respect to x. Then with respect to y, so y goes from 1 to 2, dx dy, and this would be equal to 1. And in this way we will be able to find the value of k. So let's first do this inner integration separately, then we will do the outer integration. So x goes from 0 to 1, x plus 2y dx. So it will be equal to x squared by 2 plus 2xy. X goes from 0 to 1, which will be equal to half plus 2y. Now we can put it here. Y goes from 1 to 2, half plus 2y dy. So here we have left k. It will become y by 2 plus 2y squared by 2, that is just y squared. It will go from y equals 1 to y equals 2. So k, now we put 2, so it will become 1 plus 4, that is 5, minus, if we put 1, it will be half plus 1, that is 3 by 2. So it should be equal to 10 minus 3, that is 7 by 2. K times 7 by 2. So it should be equal to 1. So from here we can find the value of k, which will be equal to 2 by 7. 2 by 7. This question number 13 is based on the same data that was given for question number 12. So we have the same joint density function. It is fxy at x comma y. So there we did not know k, so we found it out. It was equal to 2 by 7. Now using this joint PDF, what we need to do? We need to calculate the expectation of a conditional random variable. So here the conditional random variable, which is x given y equals 1.5, and we have to find out the expected value of this. So as you know, if we want to calculate the expected value of any random variable, we need to know its distribution. So in this case we have to find the distribution, in this case we have to find the expectation of a conditional random variable. It means that we need to find the conditional PDF. So we need to find out the conditional PDF of x given y has taken value 1.5. So once we know this distribution, we will be able to find its expected value also. So it will be, so as you know, any conditional distribution can be written as the joint. So what will be the joint in this case? Joint will be just the joint PDF at x and y takes value 1.5 divided by the marginal of y at 1.5. So the event over which it is conditioned, so that we put in the marginal in the denominator. So the marginal of y here at 1.5 we can write as the joint PDF we have to integrate. So k we can take outside, 2 by 7, and we will integrate it over the full range of x because we want the marginal of y. So x goes from 0 to 1, and x plus, in place of y we can put 1.5, so 2y will become 3 dx. So when we integrate it, it will be x squared by 2 plus 3x, x from 0 to 1. So if we put x equals 1, and we don't need to worry about x equals 0 because the expression will become 0 here. So 1 by 2 plus 3. So it will be 6 plus 1, 7 by 2. So 2 by 7 times 7 by 2. So it comes out as 1. Okay, so the marginal of y at 1.5, it is simply equal to 1. So now we can find out the conditional PDF very easily. In the numerator we will put the joint PDF. It will be 2 by 7 times x, we will leave as it is, x plus 2y. 2y means 3, and the marginal of y at 1.5, it is equal to 1. So the PDF of x given y has taken value 1.5. So this is the PDF of the conditional random variable that we have found out. Now we need to find the expected value of this conditional random variable. So expected value of this conditional random variable x given y equals 1.5. So as always, what we will do, we will integrate x times this distribution of this random variable. In this case, it is conditional PDF x. We will integrate it with respect to x. So, and x goes from 0 to 1 over the full range of x. So here we have the conditional PDF of this. So it will be 2 by 7 x we can take inside. So it will be x squared plus 3x. This is being integrated from 0 to 1. 2 by 7 x cubed by 3 plus 3x squared by 2. X goes from 0 to 1. So when we put its value, so putting x equals 1, it will be 1 by 3 plus 3 by 2, which will be equal to 2 by 21 plus 6 by 14, which will be 42, and 4 plus 18, which is 22 by 42. So the expected value of x given y is equal to 1.5. It is equal to 11 by 21. So if we calculate it, 11 by 21, it is equal to 0.52. So this is the expected value of this conditional random variable x given y has taken value 1.5.